Welcome to My Secret Math Tutor. For this video, we want to start our work with the basic rules of derivatives. So essentially, we have some sort of function, and we're curious, what is its derivative? Now in calculus, there's tons of different rules for derivatives, and in this video, we're just going to start off with the very basics. So when you're done with this one, go ahead and watch my video on, say, the power rule, product rule, quotient rule, and chain rule, and you should have a good idea for derivatives. All right, let's go ahead and look at some of the basics that we need to know. The very first thing that I want to point out is that I'll often use this little notation known as the derivative operator. Okay? So what its job is to do is to say I want to take a derivative of a piece of a function. So you can think of many other different operators, like here's one when we were doing the square root of, say, a number. You know, this says I want to take the square root of 4. And just like this is an operator, I use it when I want to take the derivative of something. Now, as soon as it's done taking its derivative, then it's completely gone. So as soon as I'm taking the square root of 4, it's also completely gone, and I just write the result. Okay? So watch for this guy to show up in many different locations. All right, let's see what we have for some of the basics. The very first thing that you want to know about derivatives is that you can split them up over addition and subtraction. So think of a little situation like this. Maybe I'm taking the derivative of 5 plus or minus x. And I can actually take this derivative and apply it to both of those terms. That way I'm taking just the derivative of 5 or just the derivative of x. And this is a really good handy rule when you have many different pieces to your function. It allows you to break up that derivative among all of those pieces. The next is what to do when you have a derivative of a single constant. So maybe like the derivative of 7, or this could be 5 or 6, who knows. When you take the derivative of a single constant, you get 0. So just 0. Now keep that in mind that it's completely different if you take the derivative of a single x. That derivative is actually 1. When we get to the power rule, you'll see what we do for higher powers of x, like x squared and x cubed, but know that a single power, you get 1. All right. Now, we also have a rule for what to do when constants are multiplied by something. So think of 3 multiplied by x squared. Now, in a situation like this, we can actually move that constant out in front of our derivative. So then I'm looking at 3 multiplied by the derivative of everything else. Now, this looks like it's almost a similar rule to this one up here. After all, they both deal with constants, but they are different. Remember, in this one, we have a constant all by itself, so it's a single constant. And this one, it's a constant multiplied by something, so it moves out front. Okay? All right, and the last of our basics is a really, really neat one. This is when you take the derivative of a natural exponential, so e to the x. When you take its derivative, you get the same thing back, so it doesn't change it. So this is a really handy one, and it's why you often like to see e to the x in a lot of your calculus problems, because you know its derivative is just the same as itself. All right, so let's play around with these basics by looking at lots of different examples and see how it works, okay? All right, let's do this first one. I have the function f of x equals 5 times the square root of x. I'm curious, well, what is the derivative of this function? So I want to think what happens when I take the derivative of 5 times the square root of 2. Okay? Now think very carefully about what's going on here. This, since there is no x in it whatsoever, is simply a constant. And, of course, according to our basic rules, the derivative of a constant is 0. So I can say that the derivative of this function f is 0. Just like that. All right, let's do something with a few more things in it. In this next one, we want to take the derivative of 3 plus x. So we want to take the derivative 3 plus x. Okay. Now notice how this one has two different pieces to it. And so we want to think of taking the derivative of each of them. And we can do it because they're connected using addition. So now I want to know what is the derivative of 3 and what is the derivative of x. Well, again, there's two more derivatives that come right off of our basic rule sheet. The derivative of a constant would simply be 0, and the derivative of a single x would be 1. So I could simplify all of this and say, what is the derivative of f? Well, it's simply 1. All right, not too bad. Let's look at a few more. Let's see if we can take the derivative of 5x plus 1. derivative of f. We want the derivative 5x plus 1. Okay. Just like before, I can see that I have two pieces that are being combined using addition. So we'll imagine taking our derivative operator and putting it on each of those pieces. So now we want to know, well, what is the derivative of 5x? And what is the derivative of 1? Now, in this first little piece, I have a constant multiplied by x. So I'm actually going to take this 5 and move it out in front of my derivative operator. So 5 times the derivative of x plus the derivative of 1. Okay, and now I have my derivative on these nice little single components here, and we can take the derivative of each of those. So 5 times the derivative of x is 1, plus the derivative of a constant, 0. So I know that the derivative for all of f is simply 5. All right, not bad. This next one has a bunch of different pieces to it. Definitely put your thinking caps on and see how we go through this one. So we need the derivative of x minus 3x plus the square root of 5. Okay, so even though I got three pieces, they're all connected using subtraction or addition. Let's take our operator here and put it on all of those pieces. So now I'm looking for the derivative of x minus the derivative of 3x and the derivative of the square root of 5. Okay, now two of these aren't so bad. The derivative of x is 1, and the derivative of a single constant is 0. This one we have a constant multiplied by an x, so we're going to move that constant out in front of its operator. So derivative of x is 1 minus 3. Still need to take the derivative of x plus 0. Okay, so now this is the last derivative I have to do, and of course the derivative of x is 1. Alright, so what do we really have left? So the derivative of f is 1 minus 3, or a negative 2. Alright, looking good. Hopefully it's starting to get a little bit more solid. Let's look at one last example, and we'll see how it goes. This last one, I have f of x equals 3 times e to the x minus a 4x. Alright, so our derivative of f. We need to figure out the derivative of 3 e to the x minus 4x. Alright, so we'll start off by taking our derivative operator, putting it on each of the pieces. So now we're looking at the derivative of the first piece minus the derivative of the second piece. Okay, each of these have a constant multiplied by something. Constant multiplied by something. So we'll move each of these constants out in front. So 3, the derivative of e to the x minus 4, the derivative of x. All right, now we can take care of each of these. The derivative of e to the x, that's our special one, is the same as e to the x. Nothing changes. The derivative of x is 1, so we have minus 4 times 1. All right, let's write down everything we have left over. So the derivative of f is 3e to the x minus 4. And now you're done. So you can see that as you really take these basic rules and start to combine them, you can do the derivatives of some pretty neat functions. Now, of course, this isn't all of the rules for derivatives. Again, go ahead and check out my other videos for the power rule, product rule, quotient rule, and chain rule, so you can do even more complicated derivatives. All right. If you'd like to see some more videos, please visit mysecretmathtutor.com.